Welcome to day 2 of solving trig equations. These are ones that involve factoring. So here's a typical problem, cosine of x minus 2 sine x cosine x equals 0. And notice again our domain restriction. So I'm looking at this and I notice that both of these terms of this binomial have cosine in them. So if I factor out cosine, I can set each of these factors equal to 0. And of course, over here on the left, when does cosine equal 0? That happens twice, okay, at pi over 2 and 3 pi over 2. So there's some answers. And when does sine equal 1/2? Well, we know that the first angle is pi over 6. And then sine is positive in the second quadrant. So if the reference angle is pi over 6, to get there, it would take 5 pi over 6. And there's our answers. There's 4 of them in that case. So this is called factoring out a common term. Now, the other one you're going to have to deal with is something like this, right? 2 sine squared minus 7 sine plus 3 equals 0. This looks like just good old factoring, right? So I think 2 sine of x times sine of x would definitely take care of this 2 sine squared. And to get 3, I think I'm going to go -1 and -3. Now, if I check my multiplying here, inside is -1 sine x, and outside is -6 sine x. Together, that's -7 sine x. We know this is factored correctly. So let's set each of the factors equal to 0. Now on the right side, we're going to have sine of x equals 3, which I think the biggest value sine can never get bigger than 1. So this is a case of an extraneous solution, right? We've seen that before with absolute values and logarithms. On the left-hand side, if we go ahead and solve for sine, okay, when does sine equal 1/2? Well, we can utilize our triangle here, and I think pi over 6 would be our reference angle. And it's like, well, where else is sine positive? I believe sine is positive in this quadrant here. So to get there would take 5 pi over 6. So here's a case where there's only 2 solutions. This is what factoring is, okay? So thank you very much.